Today we are going to learn about the solar system. When it comes to our solar system, there are two major groups of hypotheses as to where our solar system came from. The first hypothesis about the creation of our solar system is the encounter hypothesis. This hypothesis says that the creation of the planets, moons, etc. occurred by some random encounter, a comet or a star, with our pre-existing sun. However, this theory, the encounter theory, has major weaknesses. It doesn't answer the question, where did our sun originate? And it doesn't account for the fact that stars do not get that close to each other. The second, more believable type of hypothesis around the origin of our solar system is the nebular explanation. This suggests that the creation of the entire solar system, including our sun, happened at the same time. The most popular of these nebular theories is the protoplanet theory, which was developed by a German astronomer. There are multiple stages of the protoplanet theory. 5 stages to be exact. Stage 1 of the protoplanet theory says that it began as a great nebula of hydrogen gas and dust, which cooled and shrank in size. Step 2, most of the mass went to the center to form the proto-sun. Step 3, the leftover gas and material condensed into whirlpool-like spheres called protoplanets. Step 4, the central mass ignites to form the sun, and the solar wind blows excess gas out of the solar system. Step 5, the protoplanets develop into the planets we see today. So to repeat, Step 1 of the protoplanet theory is that we began as a great nebula of hydrogen gas and dust, which cooled and shrank in size. Step 2, when this happened, most of the mass went to the center to form the proto-sun. Then, Step 3, the leftover gas and material condensed into whirlpool-like spheres called protoplanets. Step 4, the central mass ignites to form the sun, and the solar wind blows out the excess gas. So it leaves the excess gas leaves our solar system. And Step 5, the protoplanets develop into the planets we have today. When we look for evidence of the solar system formation, we go back to the 1980s, when the first telescopic photograph was taken of a developing solar system around the star Beta Picaris, which is 64 light years from us. We are still learning about our solar system. We know that it formed between 4.5 to 5 billion years ago. The sun is near the center of our solar system, and the major planets revolve counterclockwise around the sun in a flat plane. The major planets orbit not in a circle shape, but in an elliptical shape path. So the paths of the orbits are ovals or elliptical shaped. The sun is the primary source of energy for Earth's atmosphere and surface. Here are some properties of the sun. The sun is an average yellow dwarf star. It's a sphere of hot gases, approximately 864,000 miles in diameter. 99% of the mass of the solar system is our sun. The sun uses nuclear fission at the core to make energy. The sun combines hydrogen atoms to produce helium plus energy. and the sun needs high temps and pressure for fusion. Solar energy is energy that spreads as it leaves the sun. It takes approximately 8 minutes for this solar energy to reach Earth from the sun. Less than 2/billionth of the energy from the sun reaches Earth. The structure of the sun has different layers. The core is the center of the sun, surrounded by the radioactive zone. The surface temperature of the sun is 6,000 degrees Celsius. Sunspots are areas on the sun's photosphere, and those numbers change in a year cycle. Solar flares and eruptions can have effects on Earth, such as satellite microchips. Satellite microchips can be damaged, power grids can be disrupted, radio interference can happen when a solar flare from the sun impacts Earth.